Hi, everybody. So in second period, we had talked a little bit about the test date on Wednesday, and it felt like this week was not a great fit for a test from everybody's relative stress level standpoint. So second period wanted to bump this to Tuesday of next week. Now we'll continue to do the next or the next test stuff on Wednesday and Friday, but we're not adding to test material. Like what we got through 4.9 to 5.5 is the test material for the test. We're just gonna push it to Tuesday. So I'd like to do some review stuff today, period. That was what today was budgeted for. So we'll do that. And then Wednesday and Friday, we'll look at new stuff, like test 6 topics. We'll probably find a little bit of time, maybe 20 minutes or so a day to do some review stuff for the test 5. But that's gonna be kind of the plan. Does that work better for you guys also? Let's plan on that then. Again, like, usually not a big deal to push a test forward and to just keep doing new stuff without accumulating new test material. It means test 5 and 6 will be closer together, but it's not a big deal to me. If it helps you guys out and it feels like I got a little bit more time now to get a handle on what's going on here, that's fine. Okay. So Kairos guys, you'll be kind of my expectation to be ready to take the test on Tuesday when you get back. Is that reasonable? I just wanted to put that out there and make sure that, like, you're gonna plan on taking it next week anyways. I don't think that probably just makes life a little bit easier that it's done in class instead of having to find another time outside of class to make it up. So I figured it'd be okay, but I at least want to have a conversation about it so you at least feel like I'm listening to input. There's a reason why that's not going to work very well. Everybody cool? So I think we put up the test format before, and I've talked about it before, but I'll talk about it again just to rehash in case anybody was gone and they missed it. So again, test is in 2 parts, a calculator portion, non-calculator portion. There's going to be 10 multiple choice questions, but they'll be divided across the 2 sections. So we'll have 7 in the no calculator section and 3 in the calculator section. In the no calculator section, there will be an additional FRQ question similar to those that you saw in the 5.3 homework quiz. If you haven't completed the 5.3 homework quiz and submitted it, please do that. I graded all of those here today that people have done and entered scores in for your homework quiz. Basically, I think there were 71 total points on that one. If you had above 50, I called that a 10. Between 40 and 50, I called it a 9. 30 to 40, I called that an 8, and so on and so forth. Just like every 10 points was a band. Which I thought seemed pretty reasonable, right? Like, it's a pretty big chunk for a 5. And then on the test, then in the calculator section, there'll be 7 integral problems where I just like ask you to compute the integral. They'll be definite, indefinite, u sub, not u sub, kind of all mixed together. Maybe some that you might want to do graphically after looking at the picture on your calculator. Like no holds barred, no rules as to what you can do or not do, other than like I expect you to show work, so you can't just like type into a calculator and get an answer. I need some work to go along with it, but the trick there is going to be recognizing what you need to do for the problem, right? Usually the how is not too bad once you've recognized what to do. The how of doing it's usually not so bad. And then on the calculator section, there'll be 1 FRQ that's built around doing Riemann sums. So like, I'll give you a table of values and you'll compute like left hand or right hand or midpoint or whatever I asked for there. with the specified number of intervals and all that jazz. Okay? Does everybody feel okay on the test format there? Do you guys have homework questions you want to handle before we go on to test specific stuff or practice AP stuff? I don't know where you guys are at. Sam?
74.
5.5, number 74. Okay. Let's take a look. Some of those ones at the end are the tough boys. Let's see what we can do. Says verify that sine cube root of x is an odd function and use that fact to show that the integral from yada 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 is between 0 and 1. Okay? That's fairly helpful. So to show this is odd, I just want to do this, right? That's, well, to show it's odd, and then to do that's another step. So f of negative x is going to be sine of the cube root of negative x. And I know that negative x is really negative 1 times x, right? And I can then break the cube root at the multiplication. The cube root of negative 1 is negative 1. And I'm going to use my odd even identity for sine. Do you remember what that one says? It's sine of negative x is equal to negative sine x. And there we go. That's me showing that it's odd. So I've gone and shown that f of negative x is equal to negative f of x. Does that feel okay, Sam? Others, peoples? You follow what I did there to do that? Okay. And then it wants us to show that this integral is bound between 0 and 1. Well, it gives me a nice hint here and says that I want to use the fact that this is odd to do that. So what I'm going to do, oops, got my dx, is I'm going to use my properties of integrals to do that and break it up into the sum of two different integrals. Where I'm going to go, instead of going from negative 2 to 3, I'm going to go negative 2 to 2 plus 2 to 3. Because this, since it's odd, is just 0. Is everybody okay with that? So now all I need to do is show that this guy is between 0 and 1, right? Okay. So I know that if 0 is, or if I should say a is less than f of x less than, I guess these were, we used m and m, then the integral from a to b of m dx plus, or is less than or equal to the integral from a to b, f of x dx is less than or equal to the integral from a to b of m dx. That's a property from 5.2, I think. So all I really need to do now is take is to find a cap m and a little m and cap m, so that when I do the integral from 2 to 3, I get this guy in between the stuff, or in between the stuff I need, right? So 0 and 1. Okay. So we will have from 2 to 3, I know that what quadrant am I in on the unit circle if I'm going from 2 to 3? I'm over here, right? Pi over 2 is like 1.57, pi is 3, so I'm living in this section, right? So if I do, sine of two cubed, or cube root of 2, I mean, maybe it's over here also. The point of the matter is that this is greater than 0, right? And the same thing with, this guy, right? So I'm going to make little m 0. You okay there? The next thing I want to do is find a capital M, and I know that this is true, right? Always for sine. And it doesn't matter what the f of x is in here, right? So I'm just going to make that 1. Okay? So the integral, if a and b are really 2 and 3, because that's what I have up here, this integral is going to be 0 times 3 minus 2, which is 0. This is going to be 1 times 3 minus 2. That's 1. That's what I needed. So I used, just to reiterate, Sam, the property that I was using here was this guy. That if I have f of x bounded by some lower bound and upper bound, then the integral is going to be bounded by the integral of the lower bound and the integral of the upper bound. That's what these really are. E little m times b minus a and cap m times b minus a are really just the integrals from a to b. So that's what I used there for the second piece, which took a little bit of work because I had to build this inequality first. But once I had that, it was fairly easy. Well, once I knew what to use, building the inequality wasn't so bad. And then, yeah, so that's what I did there. Does that feel okay? So I used a bunch of properties, which is pretty typical for those later problems in the homework. It's like if you got to show something, we need some theorems to use. They were nice and they told us, laid some breadcrumbs down for us there a little bit. Oops. When they told us that we need to show that it's odd and then use that fact, that was quite helpful. Okay. Others, questions from homeworks? And this was 5.4, did you say? It was 5.5?
Yeah.
Okay. I should label that in case anybody's going back to look at it and they're like, what type of problem is this? Do you guys just want to do some of the practice AP problems then? Do you want to do FRQ or MCQ stuff? FRQs, okay. All right, so I got some of these. I think this one was on the homework quiz. Do you want to do this one? Or do you want to skip it and do something that you haven't looked at yet? Something new? Okay. This was on the homework quiz. Maybe all of these were homework quiz ones. This wasn't though, was it? I don't think this one was. Should we do this? Yeah. All right. So it says find f of 7 and then f prime of 7. Okay. So f of 7 is going to be 3 times 7 plus the integral from 0 to 7 of g of t dt. Very good so far? It's going to be 21 plus the area plus those areas, right? Everybody feel okay there? How am I going to compute this areas? I don't have a formula for g of t. Yeah, I'm just going to use geometry, right? So this is half of a circle. I heard somebody say, what's the formula for area formula for a circle? Great. What, pi r squared? What's the radius in this case? 3, right? This would be the center of my circle. So that's like my radius. And what else do we know about this area? Good. Why is it negative, Anthony? Because it's below the x-axis. Okay. Everybody good with that chunk? Then I have this piece of area, right? I'm going to compute that area. Just a rectangle, right? Length times width. So what's the length? 1. The width is then, or the height? 3. Does it matter that there's an open circle there? No. Remember that finitely many open circles isn't going to affect the area under the curve. And now we'd have to do some, what's this going to be? This is going to be 24 minus 9/2 pi or something. I'm just going to leave it as an exact answer. I suspect, no calculator question is what this was. So, does everybody feel pretty good there? What's up? 24. I got 21 plus 3. And then I have the minus the circle. The circle. Is that okay? If I want f prime of 7, well, what's f prime going to be? Derivative of 3x's and the derivative of that integral is, well, not g of t, g of x. And again, because the upper bound is just like a linear term, there's no chain rule to worry about. It's just g of x. So this is going to just be 3 plus g of 7. If I go to my graph, g of 7 is equal to 3. So everybody feel pretty good there? Find the value of x on the closed interval from -4 to 3, at which f attains its maximum value. Justify your answer. Okay, before I start on this, if we're asking for a maximum or minimum, what are we going to be using? Like a first or second derivative test, right? I need to find my critical values to start. The other thing, though, I have to consider is the interval that I'm looking over is closed, which means in addition to my critical values, I also need to consider the endpoints, okay? Before I start, as soon as I see maximum or minimum, I want to slow down and be like, I need critical values. Do I need endpoints too? And look at the interval. So if I take f prime equal to 0, that's going to be the same thing as 3 plus g of x equal to 0. Everybody okay there? I also should consider where the f prime doesn't exist. Where doesn't it exist at? Can I plug values in for x and get an answer to come out of this for all x? Yeah, does it matter that I have a discontinuity here? No, because g of 6 is still defined, it's just 0, right? It's fine. Everybody's good? Okay, so we have none from here. So I'll just subtract the 3 over. So I'm looking for the values of x, where g of x is equal to -3. Looks like that's just at x equals 3, right? Everybody happy with what I did there to find that? So I'm going to just check then. I'm going to check f of -4, f of 3, and f of, oh, I guess that's it, right? Yep, okay. All right, well, this is going to be 3 times -4 plus the integral from 0 to -4 g of t dt. It's going to be -12, and then I'm going to have minus, because I'm going to swap my bounds. And then from -4 to 0 is that area. It's a triangle. The area for a triangle is 1/2 base times height, so it's going to be 1/2 4 times 2. So I get -16 there. A bit of space. Do the same thing. Okay, no need to flip the bounds here because it's going from low to big anyway. So if I go 0 to 3, I'm looking for that area. What is that? quarter circle, right? So we'll just do, and because it's below the x-axis, I need to make sure it's negative. Let's write it that way. Okay. So to figure out which one is, we need the maximum, so we need to figure out which one of those two is bigger. Nine over 4 is 2.25, right? Pi is basically 3. 3 times 2 1/4 is going to be like 6.75, still greater than 0. So G attains its max at x equals 3, and we'd say, I want to say F attains its max at x equals 3, and f of 3 is 9 minus 9 pi over 4. Does that feel okay in what I did there? Okay. So for each limit as x approaches 0 from the left of g prime of x, and the limit as x approaches 0 from the right of g prime of x, find the value or state that it does not exist. So this is G, right? So G prime, what I'm looking for is that slope, right? If I'm coming from the left. Everybody agree? So that's just going to be negative 1/2. If I'm looking at the limit of the derivative coming from the right, I'm looking at that slope. What is that slope? It's infinite, right? Because it's vertical. So the slope of the tangent line is vertical. What do we know about that for a derivative? Doesn't exist, right? I don't know if they wanted a reason or not. Does everybody feel all right there? You could answer me when I say, do you feel all right on that? If you don't, we can elaborate. I'm happy to do so. I don't know if I'm going too fast or I'm going too slow or if I'm doing stuff that doesn't make sense, but like any kind of feedback you feel like giving me, I'd appreciate it, you know? As I'm doing this for you guys, right? If it's not being beneficial, then I stop and rewind and do it in a way that is beneficial. Is this okay? All right. The last one asks us to do the limit of this. If I'm asked to do a limit, what should I be doing? What's my first step? Yeah, who said it? Good job. Okay. So, if I do that, on the bottom I get 1 minus 1. Ruh-roh raggy. On the top, I'm going to have, if I plug negative 2 in for here, I'm going to have negative 6 plus that area, but I going from 0 to negative 2, so I want to flip it. So it's really going to be minus that area. That's going to make negative 7. Oh no, what should I do? It's indeterminate, right? 0 over 0? Yeah, slopey tallet. So when I do that, I'm going to have the limit as x approaches negative 2 of f prime of x. The 7 disappears. E to the 3x plus 5 times 3, and the negative 1 disappears. Where's the times 3 coming from? Chain rule, right? The derivative of e to the 3x plus 6 is a composition of two functions. I have to use a chain rule to differentiate it. Okay, so if I direct substitute again, and have f prime of negative 2 over 3 times this, that, times that. So I have 3 over 1 on the bottom. I know this is going to be my last step because it's not going to be indeterminate if I have a constant on the bottom. Woo! And f prime is just 3 plus g of x. And g of negative 2 is here. So I have 4/3 as my limit. These are pretty typical AP questions where they're giving you graphs and integrals of the graph and having you have to move back and forth between the graph and the integral and the derivatives and to really make sure you understand fundamentally what you're looking at and how to use or how the relationship between an integral and derivatives in the graph and all these things fit together. This is pretty typical presentation for like the conceptual understanding parts. Hard to do these if you don't understand what it is you're looking at or what you can do or not do. Do you want to do another or do you want to do some MCQ stuff?
MCQ stuff.
MCQ stuff? I think that's a good plan. I want to point out a specific type of question because it came up in second hour. So I promise you on your test that you'll see a question like 8 through 11 here, where you're going to be asked to translate from, a Riemann sum to an integral or from an integral back to a Riemann sum. That is a kind of question that you will see in your multiple choice. Should we do one of these, guys? All right, let's do 8. This came up because somebody asked about a homework question, basically asking you to do the same thing. It was like 69 and 5.3 or something. Okay, so to do this kind of a problem, there's some basic formulas that you have to remember. Ugh. Where did that go? Okay. So this stuff, you're going to be able to do a problem like this, you have to have these forms memorized. You have to know the definition of an integral in terms of a Riemann sum, and then what the parts of the Riemann sum, specifically the delta x and the xi, mean in terms of a, b, and n. Actually scoot that over. All right. Probably the easiest way to approach this is going to be start with the integral piece and build the Riemann sum from it and just see if it matches the Riemann sum that I need. It's much easier to go from integral to Riemann sum than it is to go from Riemann sum back to integral. So if it's a multiple choice question like this, I always want to start on the integral end and build the Riemann sum from it. That's typically much, much easier. And this one stinks because I have 4 of them potentially to do. Or the next one stinks even more because I have 3 integrals. I have to check all 3 of them. But, all right. So if I look here at the first one, a is 6 and b is 1. And then f of x is the square root of x. So using that, I can say that delta x is 6 minus 1 over n. xi then is, okay, b is 6 and a is 1, is 1 plus 5n times I guess I could say k in this case. They use k as their index. I don't know why it upsets me when people don't use I. So if I now plug this all in, get you out of my way. So I can say then what I have is the limit as n goes to infinity, sum I equals 1 to n of, I'm going to have 10 square root of 1 plus 5n times I times my delta x, which is 5 over n. If I check here to here, they don't match. That one's gone. My a is 1, my b is 6. I guess I should have said this is 10 squared x. My f of x here is 2x square root x. My delta x is 5 over n. I'm going to kind of blaze through this a little bit now. Is that okay? Then I'm just plugging into formulas. My xi here is going to be 1 plus 5n times I. So the limit as n approaches infinity, sum I equals 1 to n of 2 times 1 plus 5n times I square root 1 plus 5n times I times 5 over n. If I look, still not the same thing. I have this extra plus 2 out front, right? I have the 10 times k over n there and everything else, but I have that extra plus 2. That ain't gonna do it. So I plug this guys in and I'm just kind of just cranking through. If you do enough of these, you'll start to see, this is 1 plus x. Here, notice that I got the same thing as the first one, but it's not what I needed. Process of elimination says this last one's going to be it. We'll do it anyway, just so you guys can kind of see. It does check out. Again, my suggestion on these, much easier to start from the integral and build the Riemann sum. To go backwards is sometimes not real obvious how to, you have a lot of choices for like what A and B could be or how I want to build my f of x. If it's simple enough, it's usually obvious, but like one like this where, you know, like, okay, my A and B could be either one, my f of x could be either squared x or squared 1 plus x. It's not super obvious until you start trying to like make things fit what's gonna work or not. I think this is just, becomes a grinded out problem. It's maybe not as, you know, like the shortest route is not going to be shorter than doing it the other way, but the longest route here is going to be much shorter than the longest route if you try to go the other direction. Does that make sense? So again, I'll promise you'll see something like this. Oh, the other thing I want to do is I want to show you something on your calculator, because this is going to come up in the multiple choice also. Let me go back to this page. So let's say we ask you to do this definite integral. If I look at that, do we have an antiderivative formula to handle this? Is there like an obvious u substitution you can use to do this? Not obvious. There is one. We'll get to it later on how to u sub through this. But we'll spend like several topics just talking about how to like integrate some rational functions. Because that's like, could be a whole day on its own. But this, we don't have an obvious way of handling this, right? But it's a definite integral, right? It's just going to be a number. Guess what? Calculator can do any definite integral you ask it to, because your calculator can do things that are computational. Now, it can't do an indefinite integral, but it can do a definite. So if I want to do this on my calculator, I'm going to press the math button. And the command I'm looking for is number 9 that says fnint. That stands for function integration. And you know what I do now? Just type it in exactly like it looks on, like on my sheet of paper. Oops. Done.
Should we make all the questions?
Can I make all the questions like that? No, but I guarantee there'll be at least one question on your test that cannot be done any other way than using your calculator to do the definite integral. Yes. Yeah, and for sure. So you can use this to double check answers. I can even use this to a degree to check like indefinite integral answers, right? Now let's say we gave you like the easiest indefinite integral ever, right? So you know it's going to be this. Let's say you didn't. So what you could do is you could say, okay, I'm just going to make this guy an indefinite integral. Use my calc to do this. And then if I think this is the answer, I could plug that in, plug the 3 and the 2 in, and see if those two match. And if they do, I should feel pretty good that I've got the definite integral, or the indefinite integral correct.
Like if you didn't know for sure if that was it.
Right, if I wanted to check to see if x squared over 2 is the antiderivative, I turn it into a definite integral, check that on my calculator, take my antiderivative, upper bound minus lower bound, in my calculator and see if the two match. Now they may differ just like a little itsy tiny bit because the calculator is actually not doing the indefinite integral, it's doing something different. It's doing like a power series approximation of what that integral would be. I think maybe it's doing like a really fine-grained Riemann sum. I haven't looked at like the programming and what it's actually doing, but my suspicion is it's doing one or the other. So it may not be like exact, but be pretty good. So that's a nice tool, right? If you have access to the calculator, you can use that to check even the indefinite integrals by turning it into a definite integral and checking. The one thing you have to worry about though is like, you know, if you have like something with like a square root in it, you pick negative values, or you have something with a fraction and somehow you pick a value that gives you a zero denominator. So you have to be a little bit mindful about the numbers you're picking for your definite integral. But for the most part, it'll be fine. You just gotta kind of pay attention. It's like, oh, why is this giving me an error on my calculator? It's like, oh yeah, because it's I get a zero denominator, square rooting a negative, or you know, it's like something like that. We're taking the logarithm of a negative or something, you know, something you're not allowed to do. Does that feel good? I think this is a good one because this is a one where you have to use your calculator to kind of do it, because we don't know how to do the integral of cosine of e to the x. That's a big problem, right? So this is quite a difficult multiple choice question that it's quite time consuming. So it says if b is bounded between 0 and 2, what value of b is the integral from 0 to b cosine e to the x dx a minimum? So I'm going to think about this as like, no, I guess I could call that a b. Yeah. Let's try to keep the notation clean here. So I'm going to think about this as a function, right? Some function f of b. Now I want to find the minimum over that interval. So because it's asking for minimum or maximum, I know I'm going to be using a first or second derivative test. Because the interval that I'm solving over is bounded or is closed, I know I'm going to have to also check endless. Everybody feel good? So I'm going to just start by taking the derivative. Now that's really easy because the derivative and the integral, what do? Cancel each other out, because the variable is just a linear term, right? It's just a b up here. I don't have to worry about a chain rule. Everybody's good? I then take my first derivative here and set it equal to 0 and does not exist. Now let's do the dne one first. What's the, if I take e to the function e to the b, what values of b can I plug in and still get a y value, or still get an output to come out of that? All of them, right? Because I know that exponential functions are continuous across all real numbers. Okay? And how about cosine? Are there any values that I can take cosine of that don't have an output come out? No, because cosine is also continuous over all real numbers. So what's that tell me? None of those. Okay? So let's solve this. I'll do cosine inverse of both sides. What's cosine inverse of 0? No, it's not 0. It's pi over 2 plus pi k, where k is a value, or is any integer, right? Cosine is x. When x is 0, it's either pointing, the terminal side is pointing straight up or pointing straight down, as you're on the y-axis. So then b is going to be, how do I cancel out that e? Natural log. Okay. So when k is 0, I can definitely do the natural log of pi over 2, right? If k is negative 1, can I do the natural log of pi over 2 minus pi? No, because it'll be the natural log of a negative. Can't do that. If I do the natural log of pi over 2 plus pi, I should be able to do that. And I should be able to do plus 2 pi and plus 3 pi and plus 4 pi and all the plus pi's. But I don't need to consider all of them. I just need to consider them until they get bigger, as long as they're between 0 and 2. So I don't have to keep going. And I think that should do it. Just those two. Let's check real quick. Okay, so that one is between 0 and 2. And this one here is also, the next one will not be. So what I need to do then is I just need to check the integral from 0 to 0. I need to check the integral from 0 to 0.451. The integral from 0.550. And the integral from 0 to 2. How am I going to check those integrals? On my calculator. I'm using the FN int command to check all four of them. That's the one that's going to work. I know because I did it for the second hour.
EG.
I couldn't look at it. It's not